12.1 gamma. Doing our standardized test statistic, okay? Which means what? It's our t-score. We're getting a linear regression t-score. What's t equal to? How far our sample statistic, b sub 1, small case b sub 1, is the sample slope from the hypothesized slope divided by the standard error, where the degrees of freedom are n take away 2. That's kind of important. Make sure you make a note of that because it's a moving definition. Degrees of freedom went from n take away 1 on a t-test to rows take away 1 times columns take away 1 on a chi-square test to n take away 2 for test for linear regression. So here's the crying babies. What happened? This is how many times they cried. They're 4 to 10 days old. All right, so give them a little break, let them cry a little bit. But this is how much they cried, and then this is later what their IQ was tested on. And is there a correlation between these? Like, are the overly sensitive babies that are crying at 4 to 10 days, who was crying when they were 4 days old? Yeah, probably. But were you crying more than normal? Yes? And did that correlate with having a high IQ? Were they particularly sensitive? You got 38 infants. You understand what you got here. The first picture is the line of best fit against the scatter plot. The second picture is the residual plot. Now, the point about the residual plot is this scale is different. So a dot here is going to look closer to the line of the residual plot because the scale is only 90 wide, where this one's 110. Oh, well. What's the line of best fit? Take a moment and identify the line of best fit, which would be what? IQ is the output. IQ equals what? Hello? What's the intercept? Where is the intercept in the output? There's a lot of clutter there. You got to sort through it. You do the constant. Across from the constant is the intercept. 91.268 plus the slope. 1.4929 times the crime. Can you look at this? See this picture? See where this intercept is above 0? 91. What's the slope of the line? About 1.5. What's the R squared value mean in context of the question? Hello? What's the definition of R squared? Good job not breaking eye contact. What is the definition of R squared? The proportion of change in the output is going to be attributed to change in the input. So that means in this case, think about this, 20.7% of the change in IQ can be attributed to the change in the crying. Is that a lot? No. The residuals. There's the distribution of residuals. In the third picture. So we're going to use the template which we just handed you. The null. You gotta make sure you understand this. The null for linear regression is always capital beta sub 1. The true slope equals 0. Then the alternate is either this, is not equal to 0 for a two-tailed test, or is positive or negative, depending on whether we believe for a one-tailed test, whether the slope is positive or negative. So in this case, the alternate's a one-tailed test. We believe that you have to do this before you collect the data, but we believe that as crying goes up, the IQ goes up. That's what we're testing. T-test for the slope. Right, we're less than 10% of all the crying babies. And let me see something that's linear. Okay, SRS. We get a t-value, a t-score of 3.07. Now, watch this. This is kind of awkward. This is an anomaly. See this p-value? It's over here, 0.004. The p-value in that software output is for a two-tailed test. Why is that? I don't know the answer to that. Meaning, you don't have to worry about this. If you have the software output, you can choose a one-tailed test or a two-tailed test. Why they made this not equal to, maybe just point out to you, I don't know. So here, they say for a one-tailed test, we're going to take that and cut it in half. Well, either way, you're in the tail. You're going to reject it all. There is evidence of a correlation between crying and IQ. As crying goes up, IQ goes up. If you put the data in your calculator, you have to put all those 38 babies in list 1 and list 2. You would get these screenshots. Careful, there's the list. The frequency list, we don't want to use that. Right? Just put the identity element in there. But here, we're picking a one-tailed test where we believe it's a positive slope, greater than 0. Here's what we got, same output, except here, you see the calculator gave us the p-value for a one-tailed test, 0.002. So it wasn't an issue. 36 degrees of freedom, because the sample size is 38. These numbers for A and B are here. We got them from the software output. Also, this down arrow means there's a second page of output. Okay. So back to where we started. The conditions, right? We are not going to concern ourselves about the conditions. It's unlikely, very unlikely, that you would get a linear regression problem. There would be a template problem. And if you did, then more than likely the conditions would be met. We would tell you that. In the unlikely event that happens, you just write SRS, the sample is less than 10% of the population, and the data appears later. That's fine. Okay? In the unlikely event it comes up, that would be fine. We're not going to focus on conditions. What do these letters mean, these symbols mean? Okay? The capital beta refers to the parameter. The confidence interval and a test. The confidence interval was the beta lesson. The test was what we did today. So, this is essentially what we just handed out to you. If it is a hypothesis, if it is a test for the slope for linear regression, the null is the capital B sub 1, the beta sub 1, the slope equals 0. If it's the alternate, it's a two-tailed test, it's not equal to 0. The one-tailed test is positive or negative. Okay? Conditions, SRS, it appears to be linear. The box plot for the residuals is symmetric. Sample size is less than 10% of the population. That's enough to convince you know what you're doing. The t-value is this. But look at this. We could rewrite this and solve, because we're subtracting 0, that's the null. The standard error can be exchanged with the t-value. Does that make sense? The standard error can be exchanged because what happens? It's algebra 1. Multiply both sides by t, divide by the standard error. And you get b sub 1 divided by t, which is what we showed you yesterday on the, when you go here. So everybody go here in their calculator, because you weren't in the room. Go to vars 5. Right-hand arrow, you get to the drop-down menu from EQ. And you see choice 3 is a B. Then I go right-hand arrow to get to the tests. And choice 3 is the t-score. So if you did that after you ran the test, the standard error does not come out on your screen. On your calculator output. So the standard error is 0 to 10. You just paste that on the home screen, and that's what's in the beta lesson. Now you have to have data to do that. Here's what's on the formula sheet for the standard error. This is way more friendly to get that value. All right? So that's the value of the step before you expand it necessarily for a confidence interval. All right? So we're going to go to 2 questions, 15 and 17. All right, 15. There's the template, except they gave you the software output, okay? And we're saying that the null, just like when we did z-test or t-test, the null is there's nothing there. So nothing there in the context of linear regression would be the slope equals 0. Then the alternate is the slope's negative. We got SRS, dot plot appears to show negative linear relationship, and the stem plot is symmetric. Okay. So here is what we need. It's in here. So the constant's 166. That's the intercept. And the slope is essentially a negative 1.1. Except again, we have the same issue. The software output they give you is for a 2-tailed test, and we're doing a 1-tailed test. Now here it matters. This is not something to worry about for men. Okay? Apparently, when I picked this problem, I was just thinking to show you this because it came up. You do not automatically have to, in fact, never do. When in doubt, never change the p-value. Okay? In fact, if they give you software output, you can fix the software output for a 1 or 2 tail test. They just set it for a 2 tail test. Okay? So if we did this, if we look at our test statistic, now, which is a negative, the t-score, negative 1.92, we said, what is the area under the curve? We got negative 0.37. Doubling that took us at average. We wouldn't double. We would say, okay, compare this to the alpha level. We are in the tail, reject the null. Okay? There is evidence that the increase in one leads to a decrease in the other. And then 17, slope is 0. Or the slope is negative. Does drinking wine help heart disease? So you see, here's the scatter plot. So instead of giving you the output here, we have the data. So here's the scatter plot. There's the plot of the residuals, box plot, symmetric. And then we're interpreting the calculator output instead of the software output. The t-score is negative 6. The p-value is essentially 0. What do you get? An intercept of 260 is slope of negative 23. And then here's the down arrow. Because here's what else the R squared and the R value are on that page or on the second page. The likelihood of a test statistic that you got on work screen, if the null were true, is 0. There is evidence of a negative linear relationship between the two. Okay, in the 19 countries, having a glass of wine with dinner correlates with less heart disease.